Let's go ahead and jump right into lesson 10.2, which is the lesson where we are going to do design problems. So the primary thing we're going to be doing today is maximizing and minimizing data. And right here I've got a list of suggestions such as visualize, write the equations based on your information. Make sure you know what we're maximizing and minimizing. Sometimes you'll have to do substitution, so just watch out for that. And then sometimes you'll have to use a graphing utility to find the max or min. If that's the case, you'll know you have to use the graphing utility if it's not a quadratic. And I suggest that you use desmos.com for this graphing utility for this lesson. But if it is a quadratic, just a reminder, so quadratics are parabolas, right? So let's say I was trying to maximize it. The main thing you're going to be looking for is the vertex. And if you're in standard form, then the vertex is negative b over 2a. So that's the formula you'd really use for quadratic. So let's just jump right into an example. So we got a farmer who has 90 feet of fence. I've conveniently already underlined that for you. You're welcome. He wishes to build 2 adjacent rectangular pens next to his barn, with the barn wall forming one side of each pen. I am going to go ahead and visualize that. So let's say we got our little barn right here. So here's our barn wall. Barn. It's red because it's a barn. And all the cool barns are red. So we've got our fencing right here. And they're 2 rectangular pens. I don't know if these 2 pens are the same size. That's not important. I just know that this, we're going to call this side length y, so the length is y. But I do know since they're rectangular, all of these sides have to be the same length. So there's my visual. And what dimensions, so we're asking what dimensions should he make the pen so as to enclose the maximum area? So it's pretty important. We're trying to maximize area. And our area equation would be our length times our width. So I'm going to say x times y. Now the problem with this area formula is currently we have 2 variables on the right side, and I want to get it down to just 1. So that's where this 90 feet of fence comes into handy. So if we know there's 90 feet of fencing, I'm going to go ahead and take the perimeter of my fencing. I do not include the barn wall because that's just already built. So we've got 3 x's we're adding together. So we've got 3x plus the y value down here. That should give us the 90 feet because I would assume we're going to use all 90 feet because we're trying to maximize area. Now with this equation, I can go ahead and solve for either x or y. I'm going to go ahead and get the y by itself by subtracting 3x. All right, I'm going to go ahead and take that and substitute that right into this equation. Replace the y value with 90 minus 3x. I'll do this in black. So we've got our area is equal to x times 90 minus 3x. Now there are actually 2 ways to approach this problem. I'm going to show both in a second, but let's start with that formula I showed earlier. In order to use this formula right here, and I know it's quadratic because if I distribute, I should mention that, I am going to get a squared term as my, so it's in the form ax squared plus bx plus c. Well, you've got the terms there at least. I'll write it in that form. So it's in standard form now. So this is a quadratic. So if I use that formula, my a is negative 3, my b is 90. So we've got x equals negative 90 over 2 times our a value, so 2 times negative 3. So negative 90 over negative 6, which is positive 15. So I know that my x value, so these lengths, have to be 15 feet. So x equals 15 feet. We now need to find our y value. But before we do, I actually want to show the other route because I think it's good to know that there are multiple ways of solving these. So if you think about a quadratic equation, there is another trick, and it only works if you have 2 x-intercepts, so it has to at least cross the x-axis twice. But if you have 2 x-intercepts, your vertex will always be halfway between those two x-intercepts. Well, I don't know if you noticed, but, oops, this, let me circle what I'm trying to circle, and then I'll show you what I mean by this. I'm going to put that down like so. Okay, so this right here is already in x-intercept form. So I could have just said that one x-intercept was 0 because of x equaling 0. The other x-intercept would be whatever 90 minus 3x equals 0 is equal to, and that's 30. So if you have an x-intercept at 0 and an x-intercept at 30, then the vertex would be halfway between, which is at 15, because you're just averaging them. So another way you could have figured out the vertex without using our equation negative b over 2a. So let's go to our y value though. Regardless of what method you would use, you would go right here. You got your y value is 90 minus 3 times x. So I'm going to go ahead and say it's 90 minus 3 times 15, which tells us our y value is 45 feet. So I am going to put that down. So 45 feet, and we are done. Those would be the dimensions we would need. Let's go ahead and jump to another problem. So a baseball stadium normally can sell 2,000 hot dogs at a game if they charge $2.50 each. They also notice that if they raise the price by 25 cents, they sell 100 fewer hot dogs. So we're just roughly, this is what the general trend tends to be. Determine the price they should charge to maximize revenue. So let's talk about revenue. I'm going to put R for revenue. There's no picture I can draw on this, but I know I need to know what my revenue equation is. So revenue, you figure out how much you're getting by taking the cost multiplied by the quantity of items. Okay, so cost times quantity gives you your revenue. Now, we need to go ahead and actually put we're doing kind of two substitutions in this. We're going to do an equation for our cost. So looking at our original cost, you're originally starting at $2.50, so I'm going to put 2.5. But then notice that they're raising the cost by 25 cents at 25 cent increments. So X represents each increment that we do. Okay? Because we could raise it by 25 cents twice, we could raise it by 25 cents 3 times, we don't know. So there is the cost part of our equation. Let's go ahead and do our quantity equation. So we start out with 2,000 hot dogs. So we've got 2,000 hot dogs, and we're going 100 fewer, so we're taking away 100 hot dogs at each increment that we add, at each 25 cent increment. So we've got this revenue equation. This one is going to be a quadratic as well, you know, because when you multiply the final terms, you'll get a x squared, a quadratic term. So we know it's quadratic formula, or quadratic equation, so you can either use x equals negative b over 2a, or find x-intercepts. Which this one's actually really easy to do x-intercepts for. Probably a little easier than doing this formula, because in order to do that formula, we have to be able to distribute, combine like terms, and get it into standard form before we can then use said formula. Kind of obnoxious. So let's go ahead. I'm going to show both ways though really quick. So if I set both of these equal to 0, 2.5 equals negative 0.25x. And you're going to divide by negative 0.025. Sweet. And that will give you negative 10. Sorry, I didn't write it. There we go. Okay, let's go to the other one. Same idea. 2,000. Oh, I shouldn't put that down. That's our x-intercept. So x-intercept is negative 10. So let's find our other x-intercepts. We got 2,000 minus 100x equals 0. So 100x equals 2,000. This one should be pretty easy to do in your head. So you get x equals 20. So our x-intercept is 20. So the middle would be the vertex. That's an E, I promise. Ooh, my handwriting is so good. So the vertex would be negative 10 plus 20 over 2, because I'm averaging them, which is at positive 5. So that means we need to raise the cost by 25 cents 5 times. So number of times we raise the cost. So let's go back to our question. Determine the price they should charge to maximize the revenue. They want just the cost. So I'm going to go ahead and take that, and I'm going to say, well, 2.5 plus 0.25 times 5 will give me my final cost, which is $3.75. Just going to talk about the other version you could have done. I'm going to do it kind of shorthand though, so you decide what you want to do. But if you distribute everything, you just need to make sure you distribute correctly. You would have had, just put it in this box, negative 25x squared plus 250x plus 5,000. So that would be our A, that would be our B, that would be our C. So you would have negative 250 over 2 times negative 25, oops. And that would have also given you the 5 that we had down there. Okay, so that's just method 2 versus the first method. So choose your poison. All right, so let's get into some more exciting stuff. So a designer wants to manufacture storage bins in the shape of rectangular prisms. Each bin will have a volume of 10 cubic feet.